Good afternoon, I am Mr. Ish. Thank you for joining me. We're proving a specific statement over here. The natural log x is equal to natural log 10 times log of x. Essentially, you are saying the natural log of any number is always equal to its log multiplied by natural log 10. The natural log 10 here serves as a factor which explains the difference between the natural log x and the log x. How can you go about explaining this? This expression here is of good scientific practicality. You will see this type of interconversion between the two, the natural log and the log x, in a variety of chemistry, physics, and or even engineering equations, one of which, the most important or the most common, is a Nernst equation. You know, in that equation you have partly, I'm not showing you all of it, but partly minus RT over NF, natural log of a certain equilibrium. We're not showing you the entire expression. It starts, we're looking here only at this. This right here is equal to also this 0.05916 over n, a log of q. And you can see how the difference is between the two. You have RT over NF being converted into this, but this 0.05916 also factors in the difference between this natural log and log. You see the difference over here? That difference very much has to do with that interconversion between the two by means of this natural log 10 factor. We're going to prove this interconversion to be true. The way you'll do your proof will revolve around this factor natural log 10. You can very easily do it by looking at that expression here on the top and taking the log and pushing it to the other side of the equal sign. What you end up with is this: natural log x divided by log x is equal to natural log 10. The quotient of a natural log and a log is always equal to natural log 10. If you can prove this, you can show that this factor is indeed a factor in between the natural log and the log. And how can you do this? It's not too hard. If you're thinking about everything here with regards to their bases, think about that. Natural log is always a log base ex. The log is a base having a 10, and this is equal to natural log 10. Now individually apply the change of base formula. You know this, the change of base formula to the numerator and the denominator. The change of the base formula, you know, has a certain representation. Log a x is always equal to natural log x divided by natural log a. This is equal to that. You use the same formula right over here. Individually apply this change of base formula to the numerator and the denominator. In the numerator you'll get natural log x divided by natural log e. In the denominator, when you apply that same, the change of base formula, you're getting natural log x divided by natural log 10. Simplification procedures, you're looking at natural log x divided by natural log e, which is always equal to 1, times natural log 10 divided by natural log x. These cancel out, you're left with natural log 10. This right here is reconciled. Indeed, it's true that the natural log x of any number is equal to the natural log 10 multiplied by a log of that same number. Before we end this video, I'll just show you in a very quick example. Imagine your x is equal to 50. We do 50 natural log 3.912. I'll save that value. Now look at the left hand expression. We'll use the same x value of 50. We'll do 50, but we'll do log. We'll multiply it by 10 natural log, and I'm getting 3.912. If I minus it from that original saved value, it should zero out, which means I'm minusing equivalent items. Same item minus same item is always equal to 0, so we're good. This indeed is a good expression to know and to be able to prove. And that right there is the end of this video.